Hi there, well, we're looking at circle theorem. I'm your tutor, Mr. Lennon. Well, with this question, what we want to do is to inspect the circle. By inspection, we notice that we have two triangles. We have the bigger triangle, and within the bigger triangle, we have a smaller triangle. Remember, a triangle has three sides and also three angles. So this big triangle has one, and this is two, the inner angle, and three, the inner angle as well, and three sides. This small triangle, which we have two sides meeting at the center of the circle. So this point is the center of the entire circle. These two lines that proceed from the center of the circle to the circumference, they are referred to as radii. Two radii. Radii being the plural of radius. Now, we aren't able to tell what kind of triangle the bigger triangle is because we're not given an indication whether or not any of the sides are of equal length. However, if we look at the smaller triangle, we will note that two sides are of equal length. Now, let's say the question didn't give us these dashes there. How do we know that they are of equal length? Well, in every circle, all the radii are equal. So we have a radii here that, like I said, once it's proceeding from the center of the circle to the circumference is called a radii. So this radii is of the same length as this radii. That means this line and this line here are of equal length. Hence, the base angles that face these two sides, these two radii, are also equal. That's the property of an isosceles triangle. If the two sides that are equal face the two angles that are equal. Now, we should know something that all three angles in an isosceles triangle, or any triangle, all three angles in any triangle will add up to 180 degrees. Correct? Okay. Now you know. Well, if you didn't know, you know now. Now, the angle at the center of the circle is always twice the angle at the circumference. The angle at the center of a circle is twice the angle at the circumference. Okay, so this angle at the center here is 150. The angle at the circumference will be half of that. So x is equal to 150 degrees divided by 2, which is equal to 75 degrees. What's the reason? And you're going to state your reason. Angle at center equal twice angle at circumference. Okay, so that's the reason. Angle at center twice angle at circumference. So we know this angle here is 75 degrees. We found one angle of the bigger triangle. Okay, so can we find what y is? Well, angle y is actually in triangle, the smaller triangle. This is the center angle is 150. Remember, these two base angles must be equal. Since the sum of the angles in the triangle is 180, we can figure out what the sum of these two angles must be. The total of the three angles should be 180. So what I could do is to subtract 150 from 180 to find the remaining angle. So if to find y, again we subtract from 180 degrees 150 degrees. Remember to put the bigger number in front when we're subtracting. And once we get the difference between 150 and the sum of angle in triangle, we will divide that difference by 2. So what we'll have is 30 degrees divided by 2. Now remember, these two angles will add up to 30 degrees because 30 plus 150 is 180. So these two angles are sharing the same value of what? 15 degrees. So 15 plus 15 is equal to 30, and that 30 plus 150 gives us 180. What's our reason for this? Base angle our base angles of an isosceles triangle, okay, are equal. Base angles, so a symbol for angles, of an isosceles triangle are equal. Okay, of course you can always write that out when you're doing your exam. So we found y to be 15 degrees. This is also 15 degrees. Okay, so we found x and y. Now how do we find angle z? That's the bigger question. How do we find angle z? Okay, so what we can look at the fact that angle z is actually one of the angles between a side for the bigger triangle and this line here. So how are we going to do that? Well, let's look at a triangle, and we can look at some properties of triangles to help us there a little bit. Okay, so we're going to take the triangle there. Okay, and then we're going to make some little note there. All right, so if we have three triangles, remember all these three triangles, remember all these angles of a triangle, x, y, and z. Let's call this angle x, angle y, and angle z. All these three angles must add up to what? Yes, 180 degrees. Now if I put a line here, extend this line here, and I draw an angle, an exterior angle here, let's call this angle P. Angle P and angle Z must add up to 180 degrees because they're angles on a straight line. And they're attached to each other. These two angles are separated by this line here. If this line wasn't here, this would be a straight 180 degrees, half of a circle, semicircle. Okay, so these two angles Z and P add up to 180. So what is this telling us? If Z plus P equal 180, let's look at it. X plus Y plus P, when I add up these, take that off, I think I made a mistake here. Okay, so we're just trying to reason on this. Angle X plus angle Z plus angle Y, those three angles equal 180 degrees. All right, correct? The three angles in a triangle, sum of three angles in a triangle, 180 degrees. And angles P plus angle Z, angle P plus angle Z also equal 180 degrees. Angle P plus angle Z also equal 180 degrees. What does that tell us? Well, Z and Z is here. We have plus Z and plus Z here. What it's telling us is angle X plus angle Y must have the same value as P. Because when we add either to Z, we get 180. You're seeing what I'm saying there? Angle X plus angle Y, the sum of those two angles, when added to Z, give us 180. So angle P, when added to Z, also give 180 degrees. Therefore, we can conclude that angle X plus angle Y added together has the same value as P. Okay? Because when you add Z either to X plus Y or Z to P, we'll get 180 degrees, as these two equations are telling us. So therefore, what can we say? That the exterior angle of a triangle is equal to the sum of the interior opposite angles. The exterior angle of a triangle, in this case P, is equal to the sum. This is X and Y are the sum of the two interior angles. But these two angles are opposite to this P. Okay? Okay, so P is pointing straight to X and P is also pointing straight to Y. So we can say this is the interior angle Z, and opposite Z we have X and we have Y. If you want to think of it like that. Okay, so the exterior angle P is equal to the sum of the interior angle X and Y. So hopefully that made some sense. Let's look at this triangle, the external triangle, the bigger triangle here. All right, the internal triangle in the circle, the bigger one though. What are the two interior angles to z that are equal to z? Using the same concept here. P is equal to x plus y. In this case, z is equal to what? Are you seeing it? Yes. Z is equal to x and this angle here. What you gotta do, you gotta take out this line here. So let's do that. Let's take out those two lines. Hopefully you'll understand what we're doing here. I'm gonna take out this line. And I'm gonna take out this line. So in your mind, let them disappear. Okay? And I'm gonna remove this bit in between here. Okay, remove this bit as well. What are we seeing? Remember, we had a line here. So this part of it is 42, and this part down here is 15 degrees as we found. So this total angle here is a combination of 42 plus 15. So this angle between these two lines, the angle between these two lines is a combination of 42 plus 15, which is 57 degrees. Okay, so we can actually take this entire thing out. And we can put the 57 degrees right there. Okay, it's a combination of 42 plus 15. And this angle y here, this angle x right here is 75 degrees. I'm sure we can let that stay. So remember, if we have an angle here, let's call this angle P. Z plus P will add up to 180 degrees because these two angles are on what? A straight line. This is a straight line they're on, separated by just a line. So they are on a straight line, Z plus P. However, we're only looking for angle Z. Okay? And angle Z is equal to the sum of the two interior opposite angles. So angle Z, if we want to find angle Z, what would we do? Angle Z will be a combination of the two interior opposite angles, 57 plus 75 degrees. So angle Z will be 57 plus 75 degrees, 57 plus 75, 132. Okay, so hopefully 57 plus 75, I'm double check that. 57 plus 57 plus 75. Just want to make sure. Yeah, 132 degrees. Okay, and what's the reason? Exterior angle of a triangle is equal to the sum of the interior opposite angles. Okay, so hopefully that was helpful. I'm your tutor, Mr. Lennon, and see you in the next